So binomial expansion, that is when you have like a binomial to the power of 2, binomial to the power of 3, to the power of 4, and so on. But what if you have a binomial to the power of 0? What's that? 1, 1. Oops, sorry. Okay, and then if you have that same binomial to the power of 1, what's that? A plus b. If you have that same binomial to the power of 2, we know how to do that. Hey, we know that shortcut. A squared plus 2ab, thank you, plus b squared. You don't know what you want. Then a plus b cubed. Now, what we did in class was we actually multiplied it out laboriously. I'm not going to do that now. I'm just going to write out the actual answer that we got for that. It was a cubed plus 3a squared b, yeah. AB squared, good, plus b cubed. Alright, so remember we said the first one cubed, then you take the first one squared times the last one times 3. The next one you take the second term squared times the first one times 3, and then you cube the last term, alright? Then a plus b to the 4, we didn't actually look at this as a shortcut. I'm just gonna, okay, some of you might have, so it's gonna be a to the 4. Yes, there is a 6, but I'm just going to write that one next. All right, so then don't worry about these now, guys. I'm not going to take you on the shortcut. Okay, like I said, this is all kind of extra stuff. This shortcut you could be tested on, all right, that one, but it's a relatively easy one, and we did also practice it in class. 6a squared b squared plus 4ab cubed plus b to the 4th. Okay, I'm going to stop there. I'm not going to go further than that. We could go further than that. Okay, guys, so now, yes, that's my goal every day. I mean, it's only not that much more to 2 liters a day, but I'm working on it. I'm not good at drinking water, so this is my daily goal at least. Okay, guys, now what Pascal's triangle is, it is obviously a triangle. I'm going to show you now how it looks, but you can use that triangle for various different patterns. One of the patterns is actually the pattern of the coefficients of these expansions. All right, so instead of actually multiplying it out and simplifying it, you could use Pascal's triangle for it. So when you are starting Pascal's triangle, you just put a 1 at the top. Okay, then what you do is to get the next numbers, you just kind of add the numbers on either side. We say that there's a 0 there and a 0 there, all right, because there's nothing. So if I say 0 plus 1, I'm going to get a 1. And if I say this 1 plus this 0, which isn't actually there, we're going to get another 1. You see that I'm doing that correctly, yes. Okay, now, again, every time we don't have anything on either side of the 1, it's technically a 0, all right? So for the next row, we're going to say this 0 plus this 1 is 1. This 1 plus this 1 is 2. Okay, and then this 1 plus this 0 is 1. So maybe as we go further down, it will become a bit clearer. It's obviously here in the first couple of lines. But guys, every time your outer numbers are equal to 1, because it's a 1 plus a 0, all right? Then for this number now, the number that goes in between the 1 and the 2, you're going to add 1 and 2 together, you're going to get 3. And here you're going to add 2 and 1 together, you're going to get 3 again. So you always add the 2 numbers kind of diagonally above the number to get the next one. Yeah, you not then add 1, 2, and 1 all together. No, you just add 2 numbers to get another 1. Okay, again, we have a 1 and a 1. Thank you. Now for this number here, in between the 1 and the 3, in the next row, we need to add 1 and 3, so that will give us 4. For the number in between the 2 3s, we need to add those 2 3s, that will give us 6. Then again, for the number in between the 3 and the 1, we need to add them, that will give us 4. Now guys, we will go further down now, but this is how far we went when we actually wrote down the binomial expansions. So this row we call row 0. I think it is the first row, but so that the binomial expansion makes sense, we call it row 0. The next row is row 1. And then we obviously go down from there, row 2, row 3, and row 4. Now the row number corresponds with the exponent on the outside of the binomial. Right? Do we see that? So row 0 is supposed to give us the answer, the coefficients, basically, of the binomial to the power of 0. Okay. Row 1 is supposed to give us the coefficients. Yeah, what is the coefficient of A? 1. And the coefficient of B is also 1. And we're supposed to get 2 terms only, all right? Because there are 2 numbers in this row. So 2 terms. Row 2 is supposed to give us the coefficients of the binomial expansion, of the terms that we're getting when we're multiplying this out. So if our exponent is 2, we see we're getting 1, 2, 3 terms. The coefficients are supposed to be 1, 2, and 3. Sorry, 1. I was just counting there. Sorry, 1, 2, and 1. Okay, the next one, row 3. Okay, we're supposed to be getting a coefficient of 1, then a coefficient of 3, another coefficient of 3, and then a coefficient of 1 again. And then for row 4, 1, 4, 6, 4, and 1. Okay, so those will give us the coefficients of the actual terms when we multiply it up. But guys, what about the variables now? Okay, so it's all good and well, we have the coefficients, but what is the pattern in the variables? Yes.
The sum of the exponents. The row, I guess.
The sum of the row, the values in the row. Okay. Sorry. Yes, okay, let's look at the 3. I want the 3.
Yeah. That exponent is 3.
Okay.
2 plus 1. 1 plus 2. 3. Yeah.
Yes. Sorry, I did interrupt you there.
No.
You are correct. All right, that's good. Do we see that pattern that happens to the next one as well? So this exponent is 4. So the sum of the exponents of the variables there is 4. Here we have 3 and 1, 2 and 2, 1 and 3, and then 4. Okay, good observation there. That is good. How are we going to know which variable gets which exponent in which term? Yes.
Well, first A has a first of 4, then 3, then 2, then 1, and then 0.
So before you carry on, can I just do this? Can I rewrite A to the 4 as A to the 4 and B to the 0? Can I do that? Because that's going to allow us to see that pattern a bit easier. And this is A to the 0, B to the 4. Right? Because what is the integral of here? It's just 1, right? Okay, good. So I'm just going to keep a graph now. So if we look at the exponent here is 4. So the exponent of the first variable in the first term is 4. All right, that's always the same. Then in each term, as we carry on, the exponent of the first variable is decreasing by 1 each time. All right, so it's 4, then it's 3, then it's 2, then it's 1, then it is 0. And what happens to the exponent of the second variable? It's starting at 0, then it's increasing to 4. All right, so B to the 0, B to the 1, 2, 3, 4. Like that. So guys, let's quickly write out the Pascal triangle row 5 and then use that to write down the binomial expansion for A plus B to the 5. Okay, row 5, we always start with the 1 because there's 0 there, alright, so 0 plus 1. Next one, 1 plus 4 is 5. Then we do 4 plus 6 is 10. 6 plus 4 again is 10. 4 plus 1 again is 5, and then we have our 1 there. Therefore, a plus b to the power of 5. Therefore, our first term, the coefficient has to be 1, and we're going to take the first variable to the power of 5. So we're going to have basically 1a to the 5. Plus, what must my coefficient be of the second term? 5. Then remember the first variable that those exponents decrease by 1, while the exponents of the second variable increase by 1. Okay? So it's going to have to be a to the 4. And then b to the 1, because it was b to the 0 in the first step. Plus 10 a to the 3, yes, b to the 2. What you can also do, guys, you can just work with the exponents of a and just check that whatever the exponent of b is when you add it, it will give you 5. Okay, instead of thinking decreasing and increase. All right, but that's a bit too complicated. Then for the next one, plus 10. Now it must be a squared and then b cubed. Right, those two exponents will add to 5. Next one, plus 5a b to the 4 plus 1 b to the 5. Okay, now there are all sorts of other patterns as well, and we actually did used to do an investigation on Pascal triangle in the past, where the question was asking to identify all the different patterns. So there is like a hockey stick pattern, I think, like this, which they say like this is almost like a hockey stick shape. You can look at that. Wait, is it there? From the top, and then you do like that hockey stick shape. So if you add all of the numbers along the stick, and then it will give you the value in the bottom of it, if that makes sense. So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, which is 10 there. There as well, yes, yeah. So it's always from the top all the way down to that one. Yeah, there are lots of different other types as well. You can find loads of videos on this on YouTube. It's quite an interesting triangle, just all the different types of patterns that you can get there. This is the other thing. There was another thing of when you added all the numbers here, it should give you, what is it? 45. Because that one squared. Let's check quickly. 6, 16. But there is, yeah, there are lots of different patterns. But, hey, what do you say? There's a word for it. 1, 6, 7, 8. Wait, what? What's the one across? Oh, 2 to the power of, oh, I see, 2 to the power of the row number. Yes, that's true. So if you take 2 to the power of 0, that's 1. If you take 2 to the power of, 1, that's 2, which is what we get when we add them together. 2 to the power of 2 is 4, which is what you get when you add these together. If you add these together, you get 8, which is 2 to the 3. If you add these together, you get 16, which is 2 to the 4. Right, so that's the pattern. If you add all of these, you get 32, which is 2 to the 5. But yeah, I mean, that could be like a very open-ended exam question. I suppose find like 2 different patterns in this triangle. I'm not saying I will ask you that, but that could maybe be something that would come up in Olympiads. Have you seen Pascal triangle in an Olympiad question before? So now, do we have to do the math? So maybe it will come up there. It's quite an interesting thing. But yeah, this is how the triangle links to binomial expansion. But like I said, you won't be tested on it. The only way in which they could possibly test you on it is if they gave you the triangle and said, like identify the pattern and then say, okay, now use the row, row 7 to find the expansion of a plus b to the 7, something like that. But you won't be expected to actually know this triangle like off by heart, be able to set it up from scratch and then use it. Yeah. I know.
And then we actually do it.
No, the very easy math competition is fun, but the Olympiad is on your own. No, we do good. I'm not sure if you signed up for when you're really like a list of them well. That's what's called. The reverse code. Yeah, starting from the exponent of A is the exponent of the bracket. I don't like it. I'm gonna let's go, please, guys. This is examinable. All right, so this is probably in the syllabus. We're going to talk about this now. So we're skipping chapter 2 for now. We will come back to it. I just prefer working in a different order. I think it makes more sense. But we will come back to it. Complex numbers. Have you ever heard of that? Have you heard of real numbers? Real numbers?
Yeah.
Have you heard of imaginary numbers? No, let's not go down that route now. I get what you're saying, but that's not what I mean. Have you heard of maybe rephrase it non-real numbers?
Yeah.
Real numbers are non-real. Because non-real numbers are actually imaginary numbers. Okay? Another thing that I just want to throw out there, we need to readjust our thinking a little bit now, because what do we normally say? We get the square root of a negative number. What do you say?
No.
Can you find that? The square root of a negative number. If you type it into the calculator, it will say math error. Now we're actually going to calculate the square root of a negative number. Right? The square root of a negative number is actually an imaginary number. So in full, you only ever work with real numbers. In AP, we're going to work with complex numbers, which is actually a bigger set than real numbers. Complex numbers include real and imaginary numbers. Okay, so I'm going to make a note on the side. So it's a bit of a mind trick, guys. All right, it's something completely new. We're never going to do this in course. All right, this is strictly an AP thing. So complex numbers. So far in AP, we have doing like advanced or whatever else. Yeah, now we do. So I think we yay. Already we're skipping it now. I said already we're skipping it for now. We'll come back to it. Okay. So guys, I'm going to teach you the quadratic formula now, which is something that you will be doing in core in grade 11, but in core you will only ever get real number answers. Okay? In AP we're going to get complex number answers. So before I show you the formula, and before I explain to you how to use it, again, all of this is completely new, so if you're feeling a bit confused, don't stress, all right? It's almost like you walked into grade 1 now, and for the first time, you are expected to add numbers together. All right, it's something completely new, so don't stress. The first thing that we need to look at is that a complex number or complex numbers are always written in a specific form. So are written in the form. Usually they use a Z, but they can use any other letter, all right? So Z is almost like a placeholder. Z is now the name of the complex number. All right, so they can give you Z, they can give you W, they can actually give you any variable there, but it will always be written in the form A plus B I. I'm going to explain now, don't panic. Right, A is the real part of the number, of the complex number. Yes. No. I just do that for the doesn't have to. It's my way of writing it. Right, so A is the real part. A will be a number, guys, like a 2. Okay, A is just a number there. B also represents a number, but B is the imaginary part. And I, you are going to write it as I in your number when you're writing it up. So for example, 2 plus 3i. Okay, that is a complex number. 2 plus 3i. 6 minus 4i. Right. For your A and your B values to come on are numbers, and there will be an I. Okay, so I'm just going to say here, for example, Z could be equal to 2 plus 3i. No, then it's just so that it doesn't look like a 1. The I is the imaginary. Yes, so the number in front of I is the imaginary part. Oh, no.
But then that's just to say that
It's a part of the imaginary number, yes. So then a complex number consists of a real number and an imaginary number put together. All right? The real part is the one that doesn't have an I. Okay, whatever that number is. And don't worry if you confuse now, we're going to work with this for a long time. We're going to work with these a lot. You'll see. The B, that number in front of the I, that is the imaginary part of the number. But I actually has a specific value, guys. I is the square root of -1. Which up until today, if I ask you what's the square root of -1, you would say, that's not exist. Not really. You would say, oh, I can't do that. Yeah, -0.5. Okay. So guys, what this actually means is 2 plus 3 times the square root of -1. That is what that actually means. So guys, this is the first kind of like definition that you need to memorize. All right, if you see I, you need to know that means the square root of -1. Okay. What if I asked you to simplify, if you have W, and I tell you that that is 3 minus the square root of -25. Don't show it out. Okay, we're just waiting for everyone to copy this down. So guys, if you want to express that in its proper form, you always have to have an I in it. Okay, you can't leave it as the square root of -1. So what we're going to do is I'm going to write -25 as 25 times -1. Because I think I'm going to split the -25 up into a number and -1. Okay, because what is I? I is the square root of -1. So I'm going to rewrite this as 3 minus the square root of 25 times -1. And guys, does 25 have a square root? Yeah. What is it? 5. So this is 3 minus 5 times the square root of -1. And now what is the square root of -1? I. Okay, so we can write this as 3 minus 5 I. Right. That's not too bad, just something that we need to get to. Okay. Let's do another one. Let's say V is equal to 1 plus the square root of, we have 3 different numbers, yeah. 1 plus the square root of -3. Yes. Or you use the same method. The only difference here is that 3 doesn't have a square root, like 25 has. Okay, but that's not the end of the world. We're going to do the same method. We're going to say 1 plus the square root of 3 times negative 1. So guys, I always have to like isolate that negative 1 because the square root of negative 1 is I. Okay, now 3 doesn't have a square root. So we're just going to write it like this. 1 plus, we're basically splitting up that square root. I suppose you don't have to write that as a separate step. Eventually, you'll be able to go just from this, even from this first line to the answer. Right? But see, I'm just putting it up. Here, I did the same thing. The only difference was that 25 had a whole number square root. Okay. So I'm just saying the square root of 3 times the square root of negative 1. What is the square root of negative 1? I. So this is just going to be 1 plus root 3 I. Make it very clear that that I is not under the square root with that 3, please. They have to be separate, but the I and the root 3 are connected. Okay. Any questions from me?
Only ever used for,
Yes, if they are giving you something with a square root of a negative. Yeah. To show where it ends. Yes, that's why I do that. I don't know if you've wondered before why I have a little like a something called just to show where the root actually finishes. Okay, any questions so far, guys? Already found it okay? It is new, hey? Does that make sense? All right. Now we're going to talk about the quadratic formula. Now, guys, I have good news. The quadratic formula is a formula that you can use to solve any quadratic equation without having to factorize. All right, so let's write that on the slide. And this is something that you learn in grade 11, but you can use it this year if you want. There's nothing wrong with it. And solve any quadratic equation without having to factorize. In some cases, factorizing is faster than using the quadratic formula. So if you are fine with factorizing, which I think most of you are, you can keep solving it in the normal way. We are starting equations in for tomorrow. All right, so then I am just going to show you again how to actually solve it by factorizing. But you know what you do, hey? You factorize, you have the 2 brackets equal to 0, you make one bracket equal to 0, the other bracket equal to 0, and that gives you your 2 answers. Okay, so now I'm saying instead of doing that, we can use the quadratic formula to solve for x. But the nice thing about the quadratic formula is that when you have complex roots, complex solutions, you know that the word roots means solution. Now, have you heard that word before? Complex roots, complex solutions, we'll write it down somewhere. When you have complex solutions to an equation, you can't get that by factorizing. So you have to use the quadratic formula. I'm going to show you now how to do that. So firstly, every quadratic equation is of the form ax squared plus bx plus c equal to 0. I know what that means. So if you think you have quadratic equations that you might have solved last year, it would be something like x squared plus 2x minus 1 equals 0. All right. So this is just saying that any quadratic equation can be written in this form. Your highest exponent of x is 2, right? That's what makes it quadratic. All right. So ax squared. So a is the coefficient of x squared. That's what a is. We need to know what these letters represent because these letters are coming up in the formula. Okay. So a is always the coefficient of x squared. B is always the coefficient of x. and C is always the constant term. All right, so when in the formula you see A, B, and C, that's what those letters are referring to, the actual coefficients of those terms. So the quadratic formula is x is equal to, and it's a fraction, so in the numerator, minus b. And now we know that b is the coefficient of x. Plus or minus. Don't panic. Don't panic. The square root of. No. Then in the square root is this whole thing. B squared minus 4ac, close your square root. And that is all over 2a.
Okay, I don't know.
Okay, and we're just writing down the and explain. Haven't explained it. Otherwise, I mean, then you'll zone out words at the right time.
Not gonna lie, now.
It's much easier. So let me just say an example. Okay, right? Trust me.
Equals
a whole lot.
lot.
Let's remember A, B, and C are numbers, yes? So now this is saying, guys, just quickly, how many answers are you supposed to get when it's a quadratic equation? 2. Hence, plus or minus. Alright? You're going to get your one answer by this whole thing with the plus. Then you're going to change that plus to a minus, that's going to give you the second answer. So you're going to say negative b, whatever this coefficient is, you're going to change the sign. Plus, for your first answer, the square root of whatever that coefficient is squared, minus 4 times a times c, and close your square root over 2 times that number. You're going to press equal, that's going to give you your first answer for it. No, would you then, hold on. Then on your calculator, you're going to use the arrow buttons on the floor, you're going to go to this plus, you're going to delete it, change it to a minus, press equals again, it will give you a second answer. Let's do an example. 6x squared plus 2x minus 21 is equal to 0. You have to solve for x there. But you can try and factorize that, but I don't know if you can divide it to just make that up. Alright? It's possible that you can't factorize it. Which in grade 10, 4 won't happen. We'll always give you equations that you can factorize. In grade 11, 4 will give you equations that you might not be able to factorize. So let's just use the quadratic formula and see what happens. You are going to write x equals. Now, unfortunately, this formula you need to know off by heart. In AP, we do actually, I give you like the list of formulas and what it is like that. Okay, so I will give you this, but if you want to use this in a core test for exam, the formula won't give you that, so you will have to remember it. Okay, but let's just take a look. What is my b value? What is the coefficient of x? 2. So negative b, so negative 2. Right, that's what the formula is saying. Negative the coefficient of x. Plus or minus the square root of b squared. Now, what is b again? 2. So 2 squared minus 4 times a, which is what? The coefficient of x squared is a, that is 6 times c. What is my c value? Negative 21 all over 2a, 2 times 6. So guys, if it helps, sorry, if it helps, when you have your equation here, you can actually write on the side. A is 6, B is 2, and C is negative 21. Okay, then you have those values there. You don't have to keep checking the equation every time. All right, calculators out, guys. Let's all type this in. But sometimes something goes wrong with the actual typing in. So what I suggest, press your fraction button. Are we getting weird answer?
Everything was very well.
Yes, and then you press it. Yeah. Yes, there we go. All right, guys, press the fraction button. Then you're going to type this whole thing in. -2 plus the square root of, now when you type it in, you can like do it shorthand. Hey, we all know that 2 squared is 4.
And what's the plus minus?
You're going to put in a negative, and you're going to change that plus to a minus for your second answer. So it's saying plus that or minus that. This is actually 2 equations in one, 2 formulas in one. It's saying for your one answer, you're going to do -b plus that over 2a. For the second one, you're going to do -b minus that over 2a. Plus minus literally means plus or minus. It means 2 options, 2 answers. Right, over 2 times 6 equals. Well, we don't like that. Let's press SD. There we go. It's 1,71. Or, now guys, instead of typing this whole thing in again, please take your arrow button. The back arrow button is there. If you press, sorry, the forward one. If you press the back one, you're going to have to go all the way back through all of this stuff. If you press the forward one, you're going to go forward, you see there, -2, go to after the plus, press delete, put in a minus, press equals, SD, there is our second answer. -2, 0. Yeah, if they don't say otherwise. They are our 2 answers, guys. If you've got those answers by factorizing. Oh, hey. But this formula will work. This formula will give you the answers even if you could have factorized. Right, so maybe if it's one of those complicated polynomials that you're not 100% keen on factorizing, you can still use this formula and it will give you the answer. But if it's something like x squared plus 4x plus 3, rather factorize that will be quicker. Okay, but we'll do that in 4. A reminder of that. Okay, are we alright with this, guys? So far? So I just have one question. Where do we get the 4 and the 2 from? Is that just part of the formula? Yes. Is that just yeah? Okay. So that's in every term. Yeah. Wasn't it a 044? So if they say it was round to 2 decimals, we only look at the third one. You don't look at the one after. Yes. So maybe you forgot to put in this negative. Let's check. Yes. So if you forgot to put in that negative, it's giving you a negative value under the square root, in which case it will be fantastic. Are we allowed to do it before? Yeah.
We get the same one.
Yes. The only thing, guys, is using this in 4 and even in AP, you have to show this line. Okay, this is what you get your working for. So this line would replace the factorizing line, the line where you have your 2 numbers. Now, we're going to do an example with you where you actually do end up with a negative value in the square root and how you then need to handle it. Because if you're ending up with a negative value in the square root, what are we going to have to get? A complex number. All right. So that's what we're actually trying to get to today. So, sorry, let's do another example. We can know it's going through this page. Okay, so we're just going to do another example. Let me just find one here. Wait, don't write that down. Now, where do you buy batteries for calculators? Buy the batteries. No, x squared plus 2x plus 2 equals 0. That's the next one. X squared plus 2x plus 2 equals 0. Maybe it's like a ruler. Isn't it the same as a watch?
Yeah, that's it.
Here. Okay, guys, now let's just imagine that you've given this equation and you need to solve it. Okay, I think you would probably first check whether you can factor this. All right, so can we find factors of 2 that when I add them will give me 2? What are the only factors of 2? 2 and 1, right? And when I add those, it will give me 3. So there's actually no way for me to factorize this. Now guys, in 4 you won't get a question like this. All right, in 4 or in grade 10, they will always give you a trinomial that you can factorize. All right, in grade 11 they might give you something, well, not like this, but they might give you something like the previous one, where you get like decimals as your answer. Okay, now for this, as soon as you see that you can't factorize it, you're going to have to use the quadratic formula. So I'm just going to write on the side.
Use a formula first or do factorize first?
It's just because if this was one that you could factorize if you want. So you can check for factorizing, but you also don't have to. Cannot be factorized. Therefore, have to use quadratic formula. If it is a trinomial that can be factorized, it's up to you. Do you want to factorize or do you want to use the quadratic formula? But if you can't factorize, you only have one option, and that is the formula. Okay, let's quickly write the formula out again. We don't have to write it out every time you use it, but it's not on the board and we're not used to it yet. So let's write it out. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Like I said, you don't have to write it out every time you use it, but it helps if you write it out a bunch of times until you actually remember. Equals. So guys, if we're looking at this equation, what is my a value? 1. Remember, a is the coefficient of x squared. My b value is 2. B is the coefficient of x. And my c value is also 2. C is the constant term. Again, you don't have to write that out, but maybe it makes it a bit easier. Those 3 values are just written in. So now we need to sub all of that in. So it's negative b, so negative 2. Plus or minus the square root of.
How does it make it?
The formula is saying negative 2. All right, b squared is 2 squared minus 4. A is 1 and c is 2. Over 2 times a, which is 1. Now guys, presumably you would take your calculator and type it in, right? It's going to come back as a math error. Because what do we have here? What is 2 squared? 4 minus what's 4 times 2? 8. So in the square root, we're getting negative 4. The calculator can't do that. Okay, the calculator is always going to come back with a math error. Right, so I'm just going to make a note here. Math error. Therefore, calculate manually. But it's not as bad as it seems. It's really not. Okay, we're just going to leave that minus 2 as it is. Minus 2 plus or minus the square root of. We all find that that's a negative 4. Right? It's 2 squared, which is 4, minus 8, which is negative 4, over 2. Now guys, on the previous page, we practiced how to change that negative 4, that square root of negative 4. What am I going to do? I'm going to split it up into a 4 times negative 1. It's going to be negative 2 plus or minus the square root of 4 times negative 1, all over 2 again. That's what I want you to notice, that we have 2 terms at the top. Right? Because what is this? This is either plus or minus. So that is one term, that is the second term. I can't just say, oh nice, there's a 2 and a 2, let's cancel them out. Right? You cannot do that. There are 2 terms here. Okay, how am I going to simplify this now? What's the square root of 4? 2. So this is going to become 2, and what's the square root of negative 1? I. all over 2. Guys, if you feel comfortable, you can go straight from that to that. Right, so if you can start working on, if you're getting the square root of -4, you can think, what's the square root of -1? I. What's the square root of 4? 2. All right, you can do it just like that. You don't have to show this. Please write this down if it's helping you. All right, there's nothing wrong with that. But maybe after doing this for a couple of lessons, you will be able to go straight from this to 2i. And now what? Okay, so what is the suggest that we factorize in this case? Because there's a plus minus and there's a negative here in front. It's a bit complicated. But do we remember that what we just did in like grade 8 and 9? Josh, if we had one term at the bottom, what could we do? Yes. Yep. There we go. You can split the fraction up. And guys, that will always be the case in these types of questions, because when you're using the quadratic formula, you have 2a at the bottom, which is always going to be 1 term. All right, so for these questions, when you're solving for x, you will always be able to split the fraction up. So what do I end up with, guys? What's -2 divided by 2? -1 plus or minus. What is 2i divided by 2? I. Now you can leave your answer like that, but let's just add the fact that this is actually giving us 2 answers. The one answer is x equals -1 plus I. Or the second answer is giving us -1 minus I. All right, we are actually getting 2 answers, but we are allowed to leave it like that. Okay, the marker, me, I'm going to know that this is representing 2 answers. Or if you want to, you can write it as 2 separate ones. Okay, that's you're more comfortable with that. What did I do when I said this? Okay, guys, any questions, please? Yeah, I'm just checking that with you. I'm going to give you a couple of these to practice. All right, solving for x using the quadratic formula. But in the textbook, they've stated it a little bit strangely, so I don't actually. I'm just going to write down a couple for you. All right, can I move down? Yeah. Okay, so your homework, and this is going to be for Friday, right? Tomorrow you're doing 4, and on Friday we're doing 8 again. Your homework is going to be solve for x in the following equation. Using whichever method you want, if you can factorize, you can do that, but if you can't, you have to use the quadratic formula. So 1 is going to be
Right.
okay, so we go to 5. I do want to point out a couple of things. We've done a couple of that down. Then you know, if you can't read any of those numbers, maybe it's always an x squared and then an x and then obviously no x. So guys, in the first one, what is my b value? 14, negative 14, right? Minus 14x. My b value here is negative 14. So when you now put that into the quadratic formula, what's negative 14? Positive 14, all right? We haven't actually done an example where you have a negative b value, but that is what you would have to do. It's just negative whatever your b value is. Then let's look at number 4. What is my b value here? There isn't one. There isn't one, meaning it's 0. Okay? There's no x term, right? That means that technically there's a 0x. Because what's 0 times x? 0. Just 0. Alright. So in this case, you can write it on the side there. Your b value is 0. Okay. All right, so here we can cut up. So your a versus 1. A is the coefficient of x. So the number that's in front of A is 1. So A is 1, B is 0, and C is 1. No. So it's going to A is not x. The number in front of B is 1. So x squared is negative 21. It is that 125 over negative. Okay. So there's no x term option. No, any of those numbers are very doesn't have to. So you're not putting x in. Or you're putting the number. No.